Okay, so this is just part 2 of those same notes of factoring trinomials and difference of squares. So we're going to start here on this slide. Now we're switching gears again back to trinomials. The difference with these trinomials, though, as the first set that we looked at, is these trinomials are going to have a coefficient with that x squared. Whereas in all the other ones that we did at the beginning of these notes, we're just a 1x squared for every single one of them. Okay? Now we're adding in a coefficient. Sometimes it's a 2, it could be an 8, it could be any number that is attached to your leading term, your x squared term. Okay? It adds in one additional step that you need to do first. Okay? Then it turns into the same factoring that we just got done going over. Step number 1 is to factor out a GCF first, okay, if it's necessary. Okay? Sometimes it will be, sometimes it won't be, but you need to check for a GCF. If this is something other than a 1x squared, you're going to have to look for that GCF. Then, once you factor out that GCF, then the remaining piece that's in parentheses, you have to decide, can you factor that further? Okay? It might be a trinomial that you have to factor further. It might be a difference of squares then that you have to factor further. Okay? Or maybe what's left doesn't factor further at all, and then you're done after this step number 1, which is perfectly possible. Okay? So you have some options with these ones. So let's look at this first example. 2x squared minus 8x minus 42. So we're starting with a trinomial. Because this is a 2x squared, I'm going to first start by checking and seeing, do I have a GCF? All of these terms I can divide out a 2 from. Okay? 2 is the largest number that I can divide evenly by 2, 8, and 42. So that's my GCF. Okay? I also want to check to make sure I don't have any variables that are common to all 3 of these terms, which I don't. Okay? I do have x's that are common to my first 2 terms, but I don't have any x's with this last term. It's just my constant, so I cannot attach an x to my GCF, okay, because it was not common to all 3 of the original terms. So I'm just going to pull out a 2 from every one of these terms. Remember that when you're factoring out a GCF, you are dividing it out of each term. So 2x squared divided by 2 is just a 1x squared. Okay? 2 divided by 2 is 1. Negative 8x. If I divide negative 2, negative 8 divided by 2 is a negative 4. Okay, so I have a minus 4x. Then I had a negative 42. I'm dividing it by 2, so it leaves me with a negative 21. Okay, so all I did was divide each one of the original terms by 2 to get my new trinomial. That's step number 1. That was factoring out this GCF of a 2. Now, step number 2 is to check and see if this trinomial will factor any further. Since it's a trinomial, you are looking for numbers that multiply to give you negative 21, and when I add those same numbers, they have to give me a negative 4. So to multiply to give me a negative 21, I have a negative 7 and a positive 3. When I add negative 7 plus 3, that gives me a negative 4 in the middle. So my trinomial factors down. I leave that 2 out front. That GCF has to get carried along to your final answer. It does not just disappear. So I have a 2, and then now this trinomial broke into 2 binomials, x minus 7 and x plus 3. So again, just don't forget, this 2 has to get carried down to your final answer. The GCF does not just disappear. It has to get written out front of the trinomial, and then it has to get written out front of your 2 binomials. All right, let's look at a couple more examples with these. If I look at this example, I have x to the 3rd power plus 8x squared plus 16x. In this case, I don't have a constant that's out front of my leading term, so my GCF is not going to be a constant. But if you do look, every one of these terms has an x that's common to them. So my GCF here is just going to be a variable, and that's okay. I can pull out one single x out of all of these at the same time. So I just have an x to the 1st power as my GCF. Then I have a trinomial left over, x to the third. If I take out one of those x's, I'm down to an x squared. 8x squared, if I take out one of those x's, I'm down to just an 8x. And then 16x, if I take out one of those x's, I'm down to just a constant of a 16. Okay? Now I have a trinomial left inside of here that I have to try to factor. Again, this x gets carried down. Your GCF does not disappear. Now I'm trying to find multiples of 16, so numbers that will multiply to give me 16, but those same numbers have to add to give me 8. Well, 4 times 4 would give me 16. 4 plus 4 would give me my 8 in the middle. Okay, remember, if these signs are all positive, then your answer is all positive. Now, this is your final answer. Another way to write this, remember that when you have something times itself, you can simplify that by saying x plus 4 squared. Okay, remember that squared means that I'm technically multiplying this by itself, so it's a shorter way of writing that final answer. Either one is acceptable, okay, but they mean the exact same thing. Next example, I have 3x to the third plus 6x squared minus 72x. So in this case, I do have a coefficient out front of this leading term that's bigger than a 1. So chances are I have a whole number as a GCF. And I also have an x that's common to all three of these terms. So this GCF is going to be a constant and it's going to be a variable. Okay, so I'm going to have one of each, which is fine as well. So I'm going to pull out a 3x to the first power. When I do that, remember, when you factor something out, you're really just dividing it. So 3x to the third divided by 3x. It's going to give me a 1x to the second power. 6x squared divided by 3x is going to give me a 2x to the first power then. Negative 72x divided by 3x is going to give me a negative 24. It's just going to be a constant and your x's will completely cancel out. Now again, you have to check and see if the trinomial that's left over can be factored further. The 3x, the GCF, comes straight down and gets written out front of your two binomials. Right? I need numbers that are going to multiply to give me a negative 24, so they're going to have to be opposite signs, but they also have to add to give me a positive 2. 6 times a negative 4 is a negative 24. Positive 6 plus a negative 4 is a positive 2. Okay, so my final answer is 3x out front and then x plus 6 times x minus 4. All right, last two examples start out exactly the same, right? I have something larger than a 1 connected to that x squared, so I'm going to check for a GCF here first. 2x squared minus 50. Largest number I can divide evenly between these two is a 2, and I don't have any x's that are common to both. So I'm just going to pull out a constant here of a 2. Divide that out. You get an x squared left here, and you get a minus 25 left from that term. Now, at this point, we only have a binomial here, okay? So you need to check and see if it's a difference of squares. Remember, difference of squares are always a binomial. So there's a chance that this is. In this case, it is. 25 is a perfect square, and I have subtraction in between, okay? Difference of squares. Remember, it has to be subtraction, and it has to be a perfect square. In this case, it is. So again, my GCF of a 2 comes straight down, and I factor this into binomials. 25, the perfect square of it is a 5, so you can split it into a positive 5 and a negative 5 then, since it's a difference of squares. Or you can think of it as numbers that multiply to give you this negative 25, but when you add them, give you 0 because your middle term's going to cancel out. Positive 5 and negative 5 would give you a negative 25 when you multiply. Positive 5 and a negative 5 would cancel out. They would give you 0 for your middle term. Okay? So you have two different ways that you can look at difference of squares. It just depends on what works for you. Okay, last one. 4x to the third minus 196x. Right, again, start with the GCF. You can divide a 4 evenly out of both of these, and you have an x that's common to both. Okay, so I'm going to bring out a 4x. When I divide, 4x to the third divided by 4x gives me just an x squared. 196x divided by 4x gives me a 49. So I'm left with x squared minus 49. Again, what's left over is a difference of squares. 49 is a perfect square, 7 times 7. And it is subtraction in between, so I can actually factor it. So I get 4x on the outside, x plus 7, x minus 7 is the final answer. All right, again, this is the part 2 of these notes. This is number 14, the last one of the quarter. This section is going to take you a lot of practice. Spend the time going through these notes multiple times if you need to. Spend the time on the practice for these. There's a lot of different ways of factoring. You need to be really good at these to finish out the school year, for the Keystone, and for your next few years of math. It's going to be very important, so really have to spend the time on this section. And again, this is concept number 14, which is factoring trinomials and difference of squares.